Hi everyone, we're going to use the principle of mathematical induction to prove that 1 plus 5 squared plus dot 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 plus 5 to the n minus 1 equals 1/4 5 to the nth power minus 1. Excuse me. And remember that 1 really is, this is like 5 to the 0 plus 5 to the 1 plus 5 squared and so forth. So the first thing we're going to do is show for condition 1 that it's true for our first term, which is n equals 1. It means when I plug in 1 into the n's here, I should get my first term. If I plug in 2, we're not going to do that. If I plugged in 2, then I should get 6, because that would be the sum of the first two terms. So for n equals 1, we have 5 to the 1 minus 1 equals 1/4 to the 5 times 5 to the first power minus 1. So this is 5 to the 0 equals 1/2 5 to the 1 minus, this is 1/4, sorry. 1/4 minus 1. So this is going to equal 1 equals 1/4 times 4, which equals 1. So the condition 1 is true. So I'm just going to erase this, saves a little space here. So that just means 1 equals 1, and that's true. So for condition 2, we're going to assume it is true for n equals k. So just write this out. And everywhere there's an n, you're going to write k. Whoops, 5k minus a big 1. All right. Now, on condition 2, we're going to assume that it's true for n equals k and show that it's true for n equals k plus 1. So copy this down, and you're going to get 1 plus 5 plus 5 squared plus dot 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 plus 5 to the k minus 1. And your next term is going to be 5 to the k. So this means your next term. All right? And then if we had to do another term, it would be 5 to the k plus 1. Next one would be 5 to the k plus 2, and so forth. So the next one's going to be 1/4 5, and for the summation, remember this is the sum of this geometric sequence. So this is going to be 5 to the k plus 1 minus 1. Now we already know what this equals. Based off our assumption, this equals, this. So just copy that down. You get 1/4 5 to the little k minus 1 plus 5 to the k, and that has to equal that. And so we have it set. We just have to simplify this side. So again, we have 5 to the little k minus 1 divided by 4. Instead of putting the 1/4 out, I'm going to put it under here. Plus 5 to the k should equal 1/4 5 to the k power plus 1 minus 1. Now, we need a common denominator, so what I'm going to do is write this with 4. So if I put a 4 here, I have to put 1 here. So simplifying this, we get 4 to the little k minus 1 plus 4 times 5 to the little k, all divided by 4. Well, when you add these two, there's one of those 5k's plus 4 of those. So that's like 1. So you have a total of 5 of those. So 5 times 5 to the k minus 1 divided by 4. Well, using your properties of exponents, this right here equals 5 to the 1 plus k. So I'm going to call that 5 to the k. You can switch that around. K plus 1 minus 1 divided by 4, which is the same as saying 1/4 times 5 to the k plus 1 minus 1. So basically conditions, since they match, conditions 1 and 2 are satisfied and the statement is true. That's it. Thank you. Have a nice day. Bye-bye.